Okay, so first we have to find the x-intercepts by changing the y to 0. And setting each factor equal to 0. And solving for x. So 0 equals 2x. Divide by 2 there. X will be 0. X minus 1 equals 0, so x will equal 1. And x plus 2 equals 0, so x will equal negative 2. So the x-intercepts will be 0, 0, 1, 0, and negative 2, 0. Okay, the next thing is to look at multiplicity. You want to look back and see if there are exponents on anything. And there's an exponent right there on x minus 1. So that makes the 1, 0 a double x-intercept. The other ones are singles because they do not have exponents. Third, we're going to find the y-intercept, and we can do this in our graphing calculator. We want to change the x's all to be 0, or in the graphing calculator you can just type trace 0. I messed up right there. I got to get that x out and make that be 0. There we go. So in the graphing calculator we could type this all in, or we could put the equation in and say trace 0. The answer will be 0. So the y-intercept will be 0, 0. Okay, and so if we put all that together, we should be able to create the graph. See, slide this over a little bit so I have enough space. So we had a 0, 0 x-intercept, a 1, 0 x-intercept, which is a double, and a negative 2, 0 x-intercept. 0, 0 is also the y-intercept. Oh, and we forgot to talk about in behavior, so let's slide back here. In behavior is determined by how many x's we have. We have 1x here. We have x squared here, so that's 2, 3. And then we have a fourth x right here. So we have an x to the fourth. So we have an even amount of x's. And we look in the front. We have a positive 2. So we have a positive leading coefficient. Even, positive. When the arrows are getting along, so they're both going in the same direction. It's positive, so they're both going up. If you need a reminder about in behavior, I have the chart at the end of this presentation on the last slide. Okay, so both arrows going up, so now we connect the dots. We'll go through the single, there's the double, and at a double x-intercept the graph bounces and it goes up to the last arrow. And that is our first graph of our first polynomial. Okay, another example. Again, for x-intercepts, we make the y be 0, and we make each factor equal to 0. This time there's no x with this negative 1/2, so this doesn't give us an answer. We'll start with x minus 3 equals to 0, so x will equal 3. X plus 2 equals 0, so x will equal negative 2. And x plus 1 equals 0, so x equals negative 1. Multiplicity, we're going to look for x-intercepts. Exponents. And if I look up here at the top, nothing has an exponent. So it's going to be a single, and a single. On the graph, we'll have points at 3, 0, negative 2, 0, and negative 1, 0. For the y-intercept, we'll go to the calculator and type in the math problem with zeros for the x's. Let's see, that's going to give us y equals 3, I believe. So 0, 3. And the end behavior, again, look up and count x's. There's 1x, 2 x's, 3 x's. No exponents, so that's going to be an x to the third, which is odd. This time the leading coefficient's a negative number, so negative. When the arrows are odd, they're going in opposite directions. In this case, since it's negative, they'll be going down. Arrow on the left is up, and the arrow on the right is down. So let's see if we can squeeze a picture in over here. X-intercepts are at 3, negative 1, and negative 2. The y-intercept is at 3, and the left arrow is up, and the right arrow is down. So let's see if we can connect the dots. Everything's a single, so we should go right through. There we go. There's our sketch of our second polynomial. Okay, and here on the last slide, like I said, is the in behavior chart, so that you can see if we have even and positive or even and negative, what the arrows are doing. So that will help you with your graphs. Thanks.